In this tutorial, I'll show you a simple example of an AC to DC and again AC. First AC will be 60 Hz and the second AC will be 50 Hz. Okay. For that, firstly, I need a three-phase source, and source is under presently Simscape, electrical specialized power system and sources. Here is a three-phase source, and then we need VI measurement block. Okay, and three-phase VI measurement block, and connect this. And we need a power grid. Okay, and specify values like 25 E3 is okay frequency, and specify internal parameter like 10 E6. Okay, now I want to see whether the voltage source is okay or not, because sometimes it's EO. And stop time we use as 0.1. Run this model. So okay, we have to reduce our step size here. Three, click OK, and again run this. We have to reduce more. There's -5. Click OK and run this. Now it's good. So okay, our source is okay. Sometimes three-phase source gives error. Okay. Now we need a transformer because I want to convert this 25 kilovolt to 600 volt. Okay. For under power grid element, you will find three-phase transformer, 2 winding. Okay. And here, okay, no need, and connect this transformer, and let's parameter, let's its VA is 50 kVA, 50 E3, and winding 1 is 25 kilovolt, and winding 2 is 600 volt. And so it's okay. I need to convert this to rectifier. Okay, for that we need a universal base and our power electronics, and this is our universal base. Okay, now connect this to, and we have to rectify it. Okay, now number of base arms will be 3, and power electric device will be diode. So okay, now our AC signal is rectified to DC, and we need a filter for smooth DC. Okay, and series RLC branch, and it should be L, and its value like 200 E minus 6. Okay, now connect it, and also we need a capacitor. Okay, because this is a LC filter, and this value will be larger like 5000 E minus 6, and it should connect in parallel. Okay, now we need to add inverter, because after DC we need to invert this signal. Okay, is now convert to IGBT diodes. here, and we have to rotate this block. Right click, format, and flip the block left and right. Now connect this positive to here and negative. Okay. For inverter, we have to give get signal. Get signal, we have to give as PWM generator, and we need a reference signal. Our reference signal is sine wave. Okay, these are sine wave, and okay, and as this is, and our source frequency is 60 Hz, and I want this is 50 Hz. Okay, so frequency should 2 by 50. Okay, and phase, as this is 3 phase, this phase will be 0 minus 2 pi by 3 and plus 2 pi by 3. Okay, and click OK, and 3 phase 6 pulses, it's okay, and frequency take as 515 to 100, it's enough, and initial phase 0, and click OK. And we need another filter, and we need passive, and 3 phase series RLC branch. Okay, and L and 183 is enough. Let's take it to millihenry. Okay, this filter is, sorry, 21 is not, it should 2 millihenry. Okay, now connect this B and C. Okay, now we need to add capacitive bank. Okay, for that we need a parallel RLC load. Okay, and we need a final load. Here parallel RLC load, nominal face-to-face voltage, it would be about 380, frequency 60 Hz, it's okay. Active power LED 0, inductive reactive power 0, and capacitive reactive power LED 3E3. Okay, click OK, and our reactive value will look like similarly it's 380, 60 Hz, it's okay. Active power LED 50E3, and this 2 reactive power 0. Okay, and we need another VI measurement block here to measure the load voltages. Okay, and connect capacitive bank here and our final load. Okay, now we can use it current measurement now and use as level, and let's rename it as source. Okay, now here and here, current measurement no, and use as level, and ABC load. Okay, and we need from log, and its level was the ABC source. Now paste it here, click OK, and type S or reverse is source, and similarly copy it and another copy it and paste it, and this is our load voltage. Okay, and rename it as load. So okay, this is all our circuit, and I'm running this model. Okay, let's check the scopes. Okay, now you can see this is our source and this is our load voltages. Although the load voltages signal are not so quite good because I haven't tuned the mm, filter quite well. Okay, for here I have already roughly tuned the filter parameter here. Here I have chosen inductance values twice e minus 4 and capacitive reactive power is 3.5. Okay, when I run this model, you can see our output voltage is quite small. Okay, now this is our desired signal. Okay, our source voltage signal and the load voltage signal, and we have successfully converted this to 60 hertz to 50 hertz, and intermediate condition was AC to DC, and we again converted it to AC. Okay, okay, that's all for today. Thanks for watching.